Hello everyone, my name is Shruti Agarwal and today in this video I am going to explain you trigonometry, one of the most important topic of advanced maths. So without any delay, let's start. So in trigonometry, first we will discuss about trigonometric ratios. Now let's first consider a right angle triangle. Now what is a right angle triangle? A right angle triangle is a triangle whose one angle is 90 degree. And just opposite to angle 90 degree, there is a side which is called as hypotenuse. So here if we consider angle C, that is 30 degree, we can see that angle C is touching two sides, AC and BC. Apart from hypotenuse, angle C is touching BC. So this side will be called as adjacent to angle C. Now as we can see that the side which is opposite to angle C is side AB. So the side AB will be called as opposite to angle C. Now let's choose the correct side. So opposite to angle C is side AB, adjacent to angle C is side BC, and hypotenuse of side of angle C is AC. Now here we can observe four triangles. Now the given triangles are similar. Let's see how. According to the property of triangle, the sum of all the angles of a triangle is 180 degree. So we can see here that the angle is 90 degree and 30 degree. So according to this property of triangle, we can say that this angle will be equal to 60 degree in all the triangles. So as per AAA, that is angle criterion, we can say that all the four triangles are similar to each other. And as they are similar to each other, we can say that the ratios of the sides of the triangle are proportional or equal to each other. So AB, that means that is adjacent of angle A, AC, that is the hypotenuse, and BC, that means the opposite of angle A. Here if we can see, this is the adjacent of D, this is the opposite of D, and this is the hypotenuse. So through similarity we can see that AB, that is the adjacent, upon AC, that is the hypotenuse, is equal. This is the hypotenuse. If we observe this ratio AB upon BC, so AB is actually adjacent, upon BC that is opposite. So adjacent upon opposite are equal. So these ratios we have seen through similarity. Now let's observe the same thing through simulation. Now in simulation we can see when the acute angle is fixed, that is 20 degree. AB upon AC, BC upon AC, all the ratios are fixed. And when the angle is changing, then the ratios are also changing. So basically we can conclude a very important thing from this simulation. But before that, let's observe another simulation. Now in this simulation we can see that the triangle sides are different, but as the acute angle is fixed in all the triangles, the ratios are also fixed. See, now the angle is 42 degree, so the ratios are also fixed. When the angle is 50 degree, again the ratio is fixed. So we can conclude something from this simulation. So there is a very important conclusion. In any right angle triangle, if one of the acute angle is fixed, then the ratios of the sides of the triangle is also fixed. And it doesn't depend upon the size of the triangle. And when the acute angle is changing, then the ratios of the sides of the triangle is also changing. So can we say that the ratios of the sides of the triangle is dependent upon the acute angle? Yes. Such relations between the sides and angles of a triangle come actually under the branch of mathematics that is called trigonometry, where trigono means triangle and metry means measurement. So now we will define these relationship of sides and angles as follows. Now we can see here, this is a right angle triangle, so this is 90 degree, and opposite to angle 90 degree, this is a hypotenuse. If we observe angle C, we can see angle C is touching either hypotenuse or side BC. So side BC will be called as adjacent to angle C, And if I talk about the opposite of angle C, that is AB. So this is the opposite of angle C. Now sine of angle C gives you one formula, that is opposite to angle C upon hypotenuse. So opposite is actually AB upon hypotenuse is AC. If I see cosine, the formula is adjacent upon hypotenuse. So adjacent is actually BC upon hypotenuse is AC. Now what is tangent? Tangent is actually sine upon cos. So here as we are talking about angle C, so we will write angle C. So when we will divide sine upon cos, we will get this formula, opposite upon adjacent. So opposite is actually AB upon BC. Now, as we have seen from similarity, all these ratios are always fixed when the angle is fixed. So we can conclude here, C. When angle C is fixed, all these ratios are also fixed. Now let's proceed further. Now here we are talking about angle A. So the angle is changed. But whenever the angle is changed, see, the 90 degree is here only. And as I told, opposite to 90 degree is the side called hypotenuse. So whatever is the angle, the hypotenuse will always remain constant. Now let's talk about this time angle A. So if I talk about angle A, we can see that angle A is touching either hypotenuse or AB. So this will be called as adjacent of angle A. And opposite to angle A is the side BC. So this is called opposite to angle A. Now sine as per the formula is opposite upon hypotenuse. So that will be BC upon AC. Adjacent upon hypotenuse will be actually AB upon AC. And if I talk about tangent, opposite upon adjacent, so that will be BC upon AB. So these three ratios, that is sine, cosine and tangent, are actually called trigonometric ratios. Thank you so much.